Hi everyone. In this chapter, we will introduce the basic mapping mission, which is area route on DJI Pilot 2 app. We will cover these topics. If you create a new mission, you can select an area route among different types of routes. Drones can collect data based on the preset parameters within the target plane area. Both the Pilot 2 on RC and FlyHub 2 can create area route. Pilot 2 only supports 2D view when creating. On the other hand, FlyHub 2 supports a comprehensive 3D view of the mission. About the camera for the mission, you can use a mapping camera like P1 or M3E to collect photos. Other non-mapping cameras like M3T, M30, and H30 series can also use the area routes to capture photos. Note that the quality and accuracy won't be as good as you use a mapping camera. LiDAR payload like L1 and L2 can be selected to capture laser point cloud. Those data can be used to create 2D maps or 3D models. Click Fly Route, Create Route, and select Area Route. Find the area and draw an area to cover it. Press Confirm. Select the aircraft and camera. Click OK. There are two kinds of collection methods under area route, which are ortho collection and oblique collection. Previously, it was separated. Using the ortho collection, a route will be created to cover the mapping area. The default shooting angle is -90 for ortho shooting, but you can adjust it accordingly. Using the oblique collection, the drone can collect data from the side of the objects. The cost involves more flight routes and time, as well as a larger flying area. The default oblique shooting angle is -45, but you can adjust it accordingly. Oblique collection is mainly used to reconstruct a 3D map. Traditionally, you will need 4 more routes to complete an oblique mission. The efficiency can be increased by using the Smart Oblique on the M3E, M3M, and P1. Oblique collection is mainly used to reconstruct a 3D model. The critical concept of Smart Oblique is the gimbal moving around when the drone is flying. Thanks to the P1 support for more flexible gimbal angles, an oblique mission can be completed using a single flight route. During the flight, the P1 will take forward, backward, left, right, and downward photos. The gimbal on M3E and M3M only supports movement in one direction, so 2 flight routes are required. The flight speed is self-adjusted, faster for the outside area and slower for the inside. Pay attention to the flight safety because extra flight area is needed. Here's an animation video showing you how Smart Oblique on P1 works. GSD, ground sample distance, represents the distance between 2 pixels on the output result. The larger the GSD, the lower the result resolution. It is easy to understand that the closer the camera is to the target, the more detailed the photo will be. Different cameras have different GSD altitude ratios. Generally speaking, P1 is more efficient and can achieve the same GSD at a higher altitude, and the M3E is more compact and easier to deploy. Under altitude mode, you can choose from ALT, ASL, or AGL. ALT means altitude, the relative altitude to the takeoff point. ASL refers to the EGM96, geoid mean sea level. ALT and ASL have no difference if your takeoff point stays the same every time. But if you take off at different altitudes, you should consider using ASL for the same flight route altitude. AGL is short for above ground level, also known as terrain following. Please watch another video for more details. Speed means the horizontal flight speed during the mission. You can set the speed to maximum for visible light missions, such as P1 or M3E, to achieve the highest efficiency. Takeoff speed under the advanced settings means the horizontal flight speed flying towards the start point. You can adjust the takeoff speed depending on your flight environment. For an open area, you can set it to maximum. Overlap ratio is crucial for the success of the reconstruction. The side overlap ratio parallels to the flight path, and the frontal overlap ratio is along the path. The default 90 and 80% can be used for most environments, even with terrain that has slight undulations. This means you can set it at 60 or 70% for a flat area to improve the efficiency. For the undulating area, you need to raise the number to ensure the success rate. As you can see from this picture, for the same overlap ratio, there is a decent area of overlap in low area. But as the ground elevation increases, the overlap area continuously decreases and may even disappear entirely. About the photo mode under advanced settings, it's recommended to choose timed interval shot for most mapping missions. Before executing the mission, there are some important items you need to check. First of all, make sure all the firmware of the aircraft, battery, payload, remote controller, and DJI Pilot 2 app are up to date. You can check on the homepage of Pilot 2. SD card. Mapping missions usually require a high-speed micro USB card, which is C10, U1, V10, or above. During the mission, the camera will keep shooting continuously, and the SD card needs to write that data into itself. Also, remember to check the remaining space before each flight. You can see it on the top of the pre-flight check. RTH settings. After completing the mission, the drone will conduct the preset upon completion action. Return to home is recommended. A proper return to home attitude is also required. You need to set it depending on the environment. There are two kinds of signal loss action you can set. The one under the pre-flight check means what action should the drone take if the RC signal is lost when heading to the start point or coming back after the mission is finished. In this case, return to home is recommended. The other one under the mapping checklist means what action should the drone take if the RC signal is lost during the mission. If the mission area is large but safe, you can choose continue. Otherwise, you should choose return to home. At last, remember to keep the warping off. DJI Terra needs the undistorted photo for the reconstruction. Thanks for watching.